Okay. First of all, thank you for taking time. And we know that it's the end of the conference, so we really appreciate you taking the time to come and visit with us. A little bit about the company, a little bit more about who we are, then we'll go more into some practical use cases of how technology is put to play to help businesses drive more revenue, better customer service, and above all, to show that how things can come together with ways that are not really that painful, as long as the good strategies are in place. Now, as you know, we are from Verizon Communications. We are not here to sell any product, but if you haven't used Verizon Fios, you're missing a lot if it's in your area. If you haven't used Verizon Wireless, probably you haven't witnessed uninterrupted communication for a long while. So Verizon is a huge entity. We have also a big IT shop in it. Actually, we qualify to be we're a little bit bigger than any startup that you can see in the Silicon Valley. So we have a lot of resident knowledge in systems, in technologies, and in how things can come together from a technical into business perspective, business domains. This is Yogesh Sawant. He's for this conference, he is a technology evangelist. And in real life, he will tell you about what he does when he gets to talk. I am Ibrahim Itani. I'm responsible for the Verizon wireline part of the house for anything that has to do with data warehousing and analytics. So it is, as you know, Verizon is huge. So the systems that they have, or we have, is extremely huge, large, and deep. So there's a lot of collaboration in everything that we do, and we come across new technologies from time to time. So, being a big company, we do not go and change all of our operating paradigm that fast, because we want to make sure that it is something that we can put to use, and more importantly, we can benefit from. So for us, a technology yielding benefit results is something that we can use. A technology, no matter how good it is, if it doesn't bring value, we just, for us, it's something that we play with and then we move on. So today, I will be concentrating about how we really use technology to enable our business partners in running their day-to-day activities and day-to-day business. We will be talking about what made our systems work. Then we will talk about the technologies that we use at a very high level. We will not go deep into technology. I'm sure that you've attended a lot of technology seminars, and there are people who are much more smarter than us on technology, so they can speak better. But we'll tell you how we used it to benefit from it. Then we will show you a practical implementation that we put together. This is something I consider really state of the art, but it is something that we had to put in place based on the need of it, not because we can do it. Then at the end, we'll conclude with some takeaways that we can share with you. Now, as you know, the analytical domain is deep and wide, and it has multiple different maturity enablement or levels. It goes from descriptive into prescriptive. So in layman terms, this is where you can go from being blindsided if you do not use any analytical measures into the advanced part of it is action on foresight. So from blindside to foresight, and anything between goes into analytical models. So the higher gear on top of all analytics today is when you are able to do all of this using streaming analytics. So the buzzword in all of this conference, as you heard, was streaming analytics, machine learning, Spark, because these are all enablement that allows us to make decisions faster, if not faster, at least in a timely fashion. So we'll go through, what have we done to do analytics for data sets that reside in databases And what have we done for streaming analytics? So we'll take two different examples and two different implementations and show you how we have done those. Now, yet another big data platform. If you look at this topology diagram, really this can apply to any and each and every industry that you are from or you want to work with. There is nothing specific about it. It really tells the story that systems today are hybrid systems, right? You have the traditional EDWs, which is the enterprise data warehouses, and the sister of it is what we're trying all of us to work on, which are the Hadoop platforms. So for us, it was not just a big data platform. When we started working on it, we said, it has to yield results. It has to have answers for specific problems that the partners will throw at it. And this is where we came with a name called VBAP, which is Verizon Big Answers Platform. If a system is put together with no answers, I don't think that it will be used, no matter how easy and comprehensive the work has been put around it. So going into the, Yogesh will speak more about what made VBAP happen, but I'll be talking about the generalities of it. You see, you have all of your data points moving into a platform of choice based whether you want deep processing or wide processing or fast processing or you want SLAs. This is what you decide whether you want to use the EDW or the Hadoop platforms or any variances of it. And from there, all of the analytics that we spoke about, whether it is from blind side, hindsight, into foresight, all of that will happen on a layer above. What that means is that technology itself is not a mean on its own. It is not the target. The target is yielding results from the analytics. Technology will come to fill a void, right? So we should not be happy only about technology, because if we don't have a proper problem statement that we're trying to solve, it will be extremely for us to put a system in place that people can use or generate value from. I have met many people since Monday, and their struggle really was, how can I justify my investment to my upper management because we don't have working use cases yet? The question itself gives you the answer, because it should have been flipped. What are the business problems that you are trying to solve so that we can put the proper architecture around it? But that architecture needs to be elastic, it needs to be evolving, extendable, all of that. And on the higher layer that you see here, we have the users layer. So this is where you can just have a user who will be pulling simple reports up to people who want to do data sciences. And in between, you have dashboarding, you have OLAP cubing, you have interaction with applications through API, web services, and what have you. The glue that puts all of this together is a centralized engine, because the centralized engine is where all of your business rules reside. So you can have as much data as you can collect. But if you don't know what to do with it and how you can link it together and how you can act on it, it will be just a lot of data sitting in a database. Then you have managed to use your EDW as a very expensive hard disk, and you have managed to make all of your distributed platforms sitting, churning CPU cycles with no result whatsoever. So now I'll concentrate on the VBAP, the one that you see on the left-hand side, VBAP, Unstructured Data in Motion Hadoop. So for that VBAP, and again, Yogesh will be speaking more about how things came together to make VBAP, but I'll tell you about the use cases that we will be demoing for you later on. One of the main problems that all industries face is data sitting in silos, right? So in our case, for example, a customer might be touched by the dispatch department before it's touched by the engineering department to go and see where they want to connect a Fios cable or what have you. Then after they become after they are onboarded as customers, it become a care issue when people call in. So you have the silo for the VRU or the IVR. This is the voice portals. There are the usage information. What are they doing on .com? What are they doing with their video services or data services? Then it comes into, okay, what are the interaction apps that they are using? Are they active on mobile? Are they calling the call center? So from it, we used to, including in Verizon, we used to be extremely good in doing deep analysis in each of those silos on its own. But when it comes into cross analytics that goes across all of these channels, it was really very tedious. It took a lot of time, and it was not repeatable more than anything else. So this is why we had to go into cross-journey analytics, where all of the data is grouped into one place, and a lot of effort was put to go and cleanse that data and link it together. Because as you know, people who work on systems, a transaction on one system does not have the same session ID from another system or the customer identifier. So it's very difficult to just blindly go and say, if I put everything together, automatically they will join. So this is where the team spent a lot of time to put all of these data together. It's the same set of data, but now it's cleansed, it is linked, and it's put in a way that anybody can go query it and make sense of it. So now we can tell a story of someone moving from one channel to another, what they have done on .com, moving into the call center, on their mobile, all of that, and that data is all used to have a better user experience. Of course, people will start asking, what about sensitive data? All of sensitive data is masked, usually, in all of these systems. So no one is privy to know details that they should not go to. And all of this is kind of regulated. There are privacy departments. There is a lot of entities that come and govern what type of data can be shared or linked together. The second example that I want to talk about, so remember, the cross-journey analytics is about batch processing. This is data at rest. For data that is moving in streams, this is where we make use of the current technologies in the market to go link data together. First of all, ingest them, enrich them, correlate them, then see what kind of insight we can put in play to make sure that we can act on it in the real time. So bottom line is, the data is there. You use it based on the use case that you have, right? So technology, as you see, we have not talked about specific technologies because all of what we've mentioned can be done in many technologies. So you will have a technology of choice, but no matter what that is, after a while, you'll see yourself going back to the drawing board because new technology will come. So we should not be stuck about the technology itself because it's just an enabler to what we want to do. Now, I'll give now the mic to Yogesh Sawant. He will speak more about the architecture. This is our true blueprint, even though it looks generic, but this is something that you can make use of. So, Yogesh.
Thank you, Ibrahim. Are you guys able to hear me?
Yeah.
Okay. Thank you. As Ibrahim mentioned earlier, the role for this conference was technology evangelist. But in my day-to-day job, I am responsible for big data platform architecture for wireline, and also responsible for video usage analytics for Fire TV customers. We started our big data journey in early 2012 with the previous versions of Hadoop. And as you all know that Hadoop is a complicated distributed computing system consisting of multiple open source projects. So that poses us the challenges of how all these technologies adoption or technology selection around the building a big data platform, how it goes, we are challenged with that. So the approach what we had is over the years, we started when we were evaluating the technology stack, is to lay out the foundation of the enterprise integration pattern of this blueprint. So looking at this diagram, So this from bottom to top, what we have put here is a multi-layered service software architecture. And each of these layers has a set of responsibilities of execution of what it is supposed to do. So in this slide, I'll be going over how we selected the technologies and what technologies will be fitting in this particular role. And not necessarily that the technologies what we have are the only technologies out there in the market. There are other things, but based on partnering with different companies and evaluating the open source, we hashed out on this architecture. So from bottom to top, if you look at the data source layer, which is the which includes all the data sources from different systems in multiple data formats. So this is a source system which are going to push the data into your platform. The ingestion layer, the main functions of the ingestion layer is it's an universal ingestion layer which handles the data acquisition, data cleansing, and data digestion. What it means is it's an intelligent layer which automatically detects the data in various size and formats and determines whether it needs to go to a processing layer or whether it directly needs to go into a storage layer or it needs to take an action on that. So we have selected appropriate technology, which I'll be going in the subsequent slides. Once the data moves up from the ingestion layer, we have the core layer of processing. Processing has three main functions. One is to handle the data in motion, which is VBAP streams, and other two layers are related to what you can do on the batch side of the house, which is VBAP batch and the model management. VBAP streams has the functionalities of processing the data in motion. It has the roles of the scenarios where you do more of a data enrichment, data correlation, and some pattern detections, the use case which we are going to demonstrate in our demo. And in VBAP batch is where we do most of the latency, where there is no latency requirements and you want to do more of a discovery kind of analysis where you have to run high functions or more batch-oriented processes. Model management layer is where the functions of there is where you define the model, collaborations of the model. So all the code construction and the model management happens in this layer. And it has a generic model execution engine which works with multiple statistical and predictive softwares. From the storage layer, it's not something new, storage, but in the world of big data, you have different kinds of storage to handle. One is which runs on typically in HDFS and Hadoop, and others are for storing the unstructured data. Either can be stored in NoSQL stores or it can be stored on Hive things. And for the specific profile-oriented or very cache-based approach, so that's where the in-memory stores have been used. So the primary purpose on this is the storage of multiple data types in various formats for consumptions from different edge layer. Edge layer is where we do most of our consumption layers. So in that you have the discovery processes like statistical mining tools can directly access the storage component. Visualization is another thing which we had in our roadmap because of the trends what are going on the real-time streaming. The streaming dashboards are becoming a critical part where all this data being emitted out of the streaming platforms have to be visualized in real time. Plus the advanced visualizations where you want to correlate data, having Sankey kind of visualizations can be done through the visualization layer. Another core part of the edge layers are the API servers, which acts as the data, which acts as the APIs for your data exchange hub, where the data from your system gets into for different consumers, as well as it can be monetize the data by accessing from different systems. So all this API management and the upcoming trend of microservices using the domain-driven design, that's what the functions on this API layer is there. The other core layers which are very important for any organization is the cross-cutting layers or security, data governance, and system management. The role of the security layer is definition and for the privacy and the security rules, policies for data access, policies for user role access at the system level, application level, data level. From the data governance perspective, we have all the policies to be defined for the data lifecycle management, and what are the retention policies for the data, what are the policies for your data replication, data retention, what are the policies around the archival of data, how the data goes out of so all the data lineage is handled through this particular layer. System management, in the world of big data, the system management is a bit different in the way it has been done in traditional warehouse systems. So we need to have a distributed system management systems tools which can manage the not only the software systems, also the each service is running on this distributed components, real-time alerts, monitoring from the command center. So all these processes can be handled from the system management. So if you see this whole square box of the dotted lines of yellow lines, these are the core components of the Verizon Big Answers platform. And from the user persona, these are the different kind of persona which are accessing the systems. We have data analysts, business analysts, we have the data engineers. So all these engineers have different needs of the tools on this on the edge layer, which they consume either by directly having the data from these APIs, and in some cases, the data has been directly provided by accessing to the storage system by handling the proper governance. And so this is the WebApp technology stack. We made sure that we are 100% jargonified with all kind of jargon of new tools of Kafka and all those. So in the ingestion layer, we have Kafka and Flume. So Kafka, everybody might know, like it's a distributed high throughput messaging system. And Scoop for importing the data mostly from the traditional database IDBMS systems. Apache NIFI is an incubator. This is an intelligent layer which we are using to abstract all this data flow coming from, and data flow and data routing coming from different systems. Not only files, so it can handle files, it can handle messages. So Apache NIFI is the main abstraction layer which handles these intelligent mechanisms to send the data into the different ingestion technologies like Kafka, Flume, and Scoop. On the processing layer, we are using Storm, which is which is a distributed in-memory processing layer for real-time streams. And Esper is the complex event processing, which we used for our application to handle event correlation, event stream processing. And the other standard engines are MapReduce and Test, which comes on top of Hortonworks distribution. And for statistical analysis is where we are using R, Hadoop, and Mahout libraries for all the statistical and predictive modeling. From the storage layer, we are extensively using Hive and Apache SBase. And we have currently incubated one of our project on Apache Phoenix for more of real-time access, which is a SQL layer on top of HBase. And for the indexing and text-based searching, we are using Elasticsearch, which is also an open source similar technology to what Solar uses. On the edge layer, from which all the systems can access our data, is the visualization layer is built on top of D3, which is JavaScript for the data-driven documents and advanced visualization. And the API server has been built on Node.js and Squirrel SQL, which allows you to access the data. And security and system governance, these are all the open source which come along with Hortonworks, and you have the Knox, Apache Ranger, which allows you to authentication, setting the authorization policies, and other kind of system management functions and monitoring tools like Ganglia and Azure, and the governance tools like Falcon. This is on the programming languages side. This is our standardized stack, which we train our teams on. Python, Scala, which has been an emerging programming language for most of the distributed and concurrent programming. Those are our key programming languages other compared to Java. And from the scripting and high SQL and Hadoop perspective, we are using Hive and Pig as our primary scripting for our data engineers. For the universal data format, for all the data getting exchanged across the Hadoop clusters, we are using Avro as our standard data format, and that's we have standardized across our whole stack. And AngularJS is another framework which we are standardizing more on streaming API. So you might see every week there is a new technology, new projects coming on, and we have been standardizing this for a while, working with different partners to see that there is a proper support, because we can't do everything on our own. That's what the lessons we had learned. You can do a research and prototyping, but you still need a support at an enterprise level to handle a massive scale of systems. We'll be going through 2 demos from the VBAP stack. One is for the VBAP batch, and the other one is VBAP streaming. So on the VBAP batch, what we'll be showcasing is around showing a complex visualization of the journeys for cancellation of the customers across when the customers, why they are canceling. We are trying to find by correlating all the data and stitching that data together. And this all analysis is happening on Hive. So data has been ingested. There are billions of events which are ingested onto Hive, and we run this complex algorithm to stitch all this journey and the maps and the paths of the customer. And we'll be showing the tool in-house we have built using D3 APIs to build this complex visualization. And on the streaming side, we'll be demonstrating the just-in-time customer intervention. So here, as I mentioned earlier, I support video analytics. So we have around 18 million STBs, which emit around 1.2 billion logs per day. So in this demo, we are going to demonstrate that how the logs are being ingested using Kafka and Storm, and there is a real-time correlation done on the fly and emitted into different forms into streaming dashboards, as well as it is inserted into the storage medium using Elasticsearch and HBase. So from here we can move towards the demo.
All right. Can you switch to? All right, thank you. So this is the front end of VBAP. As you know, the technology stack that Yogesh has described, it is accessible by users. So we tried to do when we started working on VBAP, we wanted to make sure that there is a level of data democratization taking place, meaning data should be accessed by any user who has role to play, and it's not confined to a specific user here or there, specifically in IT or business. So everybody has access. It is profile-based to a certain set of data where they can go explore, discover, and find insights to share with their business partners to help their domain. So what I'm going to show you here, this is the front end that we have built for VBAP. As you know, VBAP is the whole framework, and this one in specific is the front end to simplify access so that people don't have to go learn languages, query languages, to go and be able to do their work. I will not be going through all of the features. It is really feature-rich. We've spent a good deal of time to perfect this system. But I'm just going to give you a flavor of how, if you have the right data and the right systems in place, how you will be able to go about accessing the data, and whatever you used to do, or the people who used to do analytics, whatever used to take you probably a couple of months to do one single discovery, you can do it here probably in less than 10 seconds. So I know that people might think that's an overstatement, but that is true. So, and the way, I will not be going through all the features, but I'll show you one way of creating an insight. So here we're connecting on Wi-Fi. Hopefully, this is reading now directly from HDFS. So there is no RDBMS or relational database involved. What you see in front of you is almost 1,000 dimensions that touches a customer, whether it is related to dispatch, repair, all of the domains that I described to you before. It's all accessible here. Here I have kind of a super access user, so I can see all of them, but not everybody have the same. So you will see the domains. So it is described in journeys, whether it's here I have only 2 journeys exposed, a churn journey and a cancel journey. So let me, for example, select the cancel journey. So here what happened, as soon as I selected the cancel journey, it went and pulled all of the correlation that happened on the journeys that constitute a cancel, meaning from pre-sale up to a cancel. Someone who ordered but did not provision, then they called in to cancel. We will not be sharing insights, but I will just show you how things can come together, because your application will be totally different from our application, but it will give you an idea. So here, we had it just to make sure that, people are not lost in the data. You have 1,000 data sets. You can either go and search for the data element that you want, or you can use popular data sets or whatever I have used first. So I'll just for simplicity, I'll be using a previous set of data that I have used. I'll be selecting provisioning status, meaning did they cancel or not. I'll be using sale to disconnect duration, order month, and cancel or disco within 30 days. So if you noticed, these are numbered, but this is really the number of steps that you have to click on to bring all of this data to visualize it in front of you. So here, these are the selected data sets that I have. I can go reorder it, because now it will be charted based on the order that I have put in. So now I'm selecting a random one, but I'll show you one that I've saved earlier. So the next step is select how do you want to visualize it. So here there is a hidden step that is not privy to all. What have happened based on the data components or the data types that I've selected, there is some intelligence to go and tell you these are the most appropriate graphs that you can use to visualize your output. So, and the set is huge, but for this specific 4 data elements that I used, it came back recommending these. So you can look at it in a pivot table, in a Sankey chart, in a node chart, in a sunburst, or in a core chart. My favorite is Sankey, because you can play with it while it's on the screen. So now it will come. You have to go and customize it, because I might have selected a lot or attributes. I don't know how it will come, but I'll show you one that we have saved earlier. I'll let it run to see how soon it will come. Usually it takes almost 7 to 10 seconds to come back, and it is now querying massive amount of data that is sitting behind it. So here what it tells you that this is, from the people who completed their order as compared to the people who canceled, right? And then this is what have happened to them in the sale to disconnect duration. Some of them had 31 to 60 days, 61 to 90 days. And this is mocked up data for you to see. It does not have to reflect reality. And then what month it was ordered in, and what is the status of it as today. So for example, you can go click on any of these nodes, and it will tell you from where they came from. And you can go and drop in, let's say, some tooltips. So here you can, for example, just if it's too busy, you can go and say, you know what, take out completes. I only want to, take out complete. I want to look only at canceled, or take out cancels. I just want to look at complete. So it gives you a lot of flexibility. This is something, a tooltip. I think this is the tooltip. The tooltip is very powerful, because wherever you go on each of these connectors, if you notice the numbers here, it will tell you the relationship node to node. In this way, you can go and do a lot of the analyses that you want. From here, you can go view the data, you can export it, you can run our Hadoop algorithm on top of it without moving one single data set outside of the platform itself. And if you, for example, this is not, usually when to do this, it's a couple of months between collecting data, because all of these are coming from different domain. Now assume you have charted it, and now you need to do a little bit of a change on how you are putting things together. Remember, this is not an OLAP cube, so do not think that you will be able to move dimensions. Let's just say that you want to go and change the order of it. I want to start by the order month. Okay, and this way it will tell me which month is more susceptible for cancels in this case. And again, this is just for the sake of demo. It does not reflect reality to what the numbers are in specific. So as you see, it's only 3 steps. If you want to reiterate, it's a 4th step. And if you want to do another dimension of analytics, then you can take it to a different level. See now, the whole analysis, the whole connection happened starting by a month, which is, for people who do interactive analysis, this is not something trivial to drop in. Remember, this is not a cube. So there's a lot of features. There are, you can take out the noise from here. There's, you can change from percentage to total, or if you want just it for a pretty presentation, you can float it up. So these are ideas for you guys if you want to work on something like this. And really, the investment in it is dedication from the team. Everything that you see is either open source or things that are readily available for any programmer. There is no intellectual property other than what we have put to make it complete for Verizon. Okay, and it's not a commercial product, so you cannot go sell it or buy it anywhere. So this is one aspect. There are a lot of other features. We can do dynamic roll-up on the fly. You can do path analysis. We can do timeline view. You can do analytics on top. You can move it into OLAP cube. This is not ready in production, but we are experimenting with multiple partners on it, so on and so forth. So hopefully this gave you an idea. Now I want to move to a different demo, which is about streaming analytics. I know many people here has been talking about streaming, but what does it mean really from a practical perspective? So what you are looking at is a mock-up of data from video channels, right? So this is not real data. And it is streaming in probably almost in an interval of 5 seconds. And here you can go and customize how frequently you want the data to be refreshed. Here we've selected a 5-minute refresh. You can go select also, you can put filters on top. You can change segments. So this is for demographics, for people who work on demographics. You can go select a certain region based on source systems. It's very profound. So the first one, now it's recalculating. It tells you, for example, on this specific example, who is watching what, not in a specific person. Here, all of sensitive information is not on this dashboard, but it will tell you, at large, who's watching what. This allows the team who, for example, in our case, who do sizing for network to know in which areas and in which states, what are the kind of adoption rate for a specific type of a channel, the timeout, for a channel, and they will be able to go and size it accordingly. There are other charts, when it comes back. For example, it tells you about specific errors that happens at an STB level or any device that we have. This is used for kind of proactive maintenance. Usually this information, if you think about it, if you don't have streaming dashboard or streaming systems, this usually is done offline, right? And some of this information is time sensitive. You want to be able to go intervene and make an action happen before the customer leaves to a certain level of frustration. So these are, this is a technology. Of course, it uses Storm and Kafka, and we have partnered with one strong partner of ours. They are here on the floor. If you want, after this session, I can tell you who those people are. But this is technology that's readily available. Anybody can make use of it, and you will be able to bring a lot of value. So if you scroll down, let's go to chat. So for example, what Yogesh is clicking on is another stream, but this one is coming from the centers, whatever mechanism happening. This is a chat session between customers and agents. So it will tell you what type of topics being discussed, which tells you what is the hot issue of the day. Then it can kind of measure, what kind of performance agents have here and there. So, and you can go change from different events. So it's you have word cloud. Really, the sky is the limit. We have limited it to these specific cases that we want to do. But you can think about your implementation, your use cases, and hopefully you will be able to put something into practical use very soon. Can you go back that one? Can you switch back to the presentation? So we are running out of time. I think we are a little bit over. Yeah. So I would like to conclude only with some observations. It's not about the technology, really. It is about the people. You need to make sure that in order for you to put all of this into play and benefit from it, and it's not just kind of technology analysis paralysis or begging for money from finance to go build a system that you don't know what kind of return on investment you will have. You need to invest in the people first. I don't say that because it's a kind of this is what everybody says. It's truly, if you do not have the right people, the right skill set, the right attitude, the people who wants to collaborate, you will not be able to get far. If you are starting or if you want to continue on this journey, make sure that you have a problem statement to solve. If you are starting from the technology stack, you've already set up yourself for failure, unless your business is in the technology. But if your business is in the services, make sure that you have a problem statement to solve. Then everything you can frame around it. Make sure that you have the right alliances within your organization, right? Going up to the top level, because when you want to go talk about it, you don't want people to be casting any doubt about the benefit of it. So you need to go prepared, knowing what you know and knowing what their problems that you're trying to solve for everybody. Industry partnership, Yogesh mentioned it. You can do a lot, but you cannot do all. Make sure that you are partnering with the right people or vendors or excuse me, or right domain experts who can really help you. You can figure it out eventually, but probably it will take you a year of pulling hair. And I'm an example of what happened to me in phase 1. So phase 2 is an example of Yogesh, where he had the right partnerships across. And don't think that the technology on its own will solve your problem. Technology is a tool. Today it's this technology, tomorrow it's a different technology. So don't get stuck with the technical details. Make sure that you have the problem statement very clear and everybody is aware of it. Lastly, the last two, expect changes, as we mentioned earlier, and most importantly, do not run the marathon before preparing for it. So you have to start slow. Start with probably the simplest use cases so that you can ground your team, ground your administration, and have a feel of the technology. And from it, everything will be really a step forward for you. So any questions will be here around, Yogesh, Sawant, myself, Ibrahim. We have, at least 5 or 10 people from Verizon as well. They can answer as many questions that you want. And thank you for so much. Hopefully, this gave you an idea of how we can put technology into practical use.